So today we'll learn to make a Sudoku solver in TC through a program. First open TC. I already did. Add the necessary header files. Fine, no more header files needed, I suppose. Now let's make some variables. First int a99 and b99 as the size of the Sudoku. Now here A is for the input, we will take input from the user, and B is for the output and for doing operations. We will do operations on B for solving the Sudoku, and we will display the output from B. So for solving a Sudoku, first see a sample Sudoku. Here it is. It's a Sudoku. First we'll make a function in which we'll pass a value for a block and the block's coordinates. Suppose this 4, its x coordinate is 0 1 2 3 4 and y coordinate is 0 1. So that function will check whether the passed value can be satisfied, can fit into this block or not. Whether the passed value is coming in the same row or column or not, or whether the passed value is coming in this square or not. So now let's make this function first. Function's name will be input value, which will take 3 parameters: int x for x coordinate, int y for y coordinate, and value to check the value which will be the value which has to be passed. Its prototype is int, because if the value is satisfied in that block, it will return the value, or else it will return 0. So first we will check horizontally and vertically. It's a simple for loop. For int I is equal to 0, I less than 9, I plus plus, if value equal to b bracket x bracket I, or value is equal to b bracket I bracket y. Now this is simple. First x is constant and the column is checked, and then y is constant and the whole row is checked. What's this now? Anyways, now if the value gets matched, it means that the value cannot come here on the xy coordinate passed, hence we return 0. First let me put a comment: scanning horizontally and vertically. Now here scanning its own square, because now we are going to check its own square. First understand a thing, that suppose we got this coordinate and we have to check its square. So its square comes at 0 1 2 3 4 5 3 4 5 and 0 1 2. These are its xy ranges, but this 4, so its coordinates are 0 1 2 3 4 and 0 1 4, 1. We have to come to its ranges from 4, 1, because the coordinates are of integer type and the sudoku is divided in 3 into 3, 3 into 3 squares. So if we multiply and divide the coordinates of the block by 3, we will get the starting ranges. For in this case, suppose it's 4, we divide 4 by 3, we get 1, and we multiply 1 by 3, we get 3. It's 3, and we add 2 to 3, 4, 5, we will get 3 to 5 x ranges. And similarly with y, we divide y by 3, get 0, here 0, and add 2, we get 2. This will work for every block. Now let's write its coding. For I is equal to x by 3 multiply by 3. Now alternate x by 3 multiply by 3 and plus 2. I less than equal to, now I plus plus. Same we'll do with j for the y coordinate. I will copy this, copy, and now we'll paste. We'll replace I by j and replace x by y. Okay. Now if any value of any block in the square matches our passed value, then we'll return 0. If bij equal to value, then return 0. Okay. Now see, if the value would have been matched up till now, then the compiler would have returned 0. Suppose the compiler has reached the position of the cursor while running actually, it means that the value hasn't matched up till now. This means that the passed value can come in the block, so we'll return value here. Now this is the coding of input value finished. Yes, input value is done now. Okay then. So let's compile first, coming correct or not. Alright. Now see carefully. The solve function, the main solve function in which we'll solve the sudoku. What we'll do in it is the top left block. We have assumed it 0 0. Its position as 0 0. The x coordinate is increasing from left to right and y is increasing top to bottom. What we'll do is we will check the block in which no value is given by the user. We will ask the user to enter 0 wherever he doesn't want to enter any value. So all the blocks in which there is 0, we will check passing the values in those blocks only. Now how we will do it? Now suppose all the black colored boxes are 0 and the red colored numbers are given by the user already. Suppose this block is 0, we will put all the values from 1 to 9 in every block and check which value can come up. So if any value can come in a block, we will put that value in the block, and if that value is incorrect that we have put in, then there will come some block in which no possible value would be there. Suppose no possible value can come in this block, it means that we have entered an incorrect value in some previous block. We are moving like this, so when we will reach here, this would have been the block previously. Suppose we have put in 6 here. Previously we have put in 6 here. It means that 6 should not come here. 6 should not come here. 6 should 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 come here will move ahead of 6 now. We'll enter 7. We will enter 7, 8, 9. Now if 7, 8, 9 does none of the three comes here, it means that previous block has a mistake. We'll come to the previous block. If there is mistake in this block also, we'll go to the previous block, and so on. If in this block we have put all the numbers from 1 to 9 and the whole Sudoku is not filled yet, it means that there exists no solution for the Sudoku. So let's start writing the code for this function. We're going to use recursive function to write its coding. So let's start. Int solve, int x comma int y. X, y are starting positions. We will start solving the Sudoku from here, and we will move like this. When we'll call this function in main, we'll put 0, 0 in place of xy. Now first make a temp variable, integer type, int temp. Later on its use is there. Now first we have to check only and only when the coordinate of the means the value of the given block is 0, else we will not check the block and move on. So if b xy equal to 0, we'll write the code in this. Now if it's 0, we'll put all values from 1 to 9 and check for int I is equal to 1, I less than 10, I plus plus. What has happened? Doesn't matter. We will put the input value in temp. We'll check whether 0 comes or the value comes. Check that I can come in this coordinate, xy coordinate. If I can come, then temp will take i's value, or else temp will take 0. Now we'll write the if condition. If temp greater than 0, that the value means the value has come in the temp variable. Now what we'll do is we'll write now coding in temp. Let us write that. Now we'll put this value. Now if the value is correct, we'll move on. If the value is incorrect, then we'll come back afterwards. Now see, now we'll move on. Now first we'll write if x and y both are 8, x equal to 8, x equal to 8 and y also equal to 8, means we have reached the end of the Sudoku. It means that no need to go ahead. Now means there is no way ahead. Then this means that we'll return 1, true. Return 1 means Sudoku is solved, returns true. Now if only x coordinate is 8, y is in between 1 to 8, then x is equal to 8. If x equal to 8, now here it will come return solve 0 comma y plus 1. Visualize this first. Suppose we have reached the end of a row. What has happened now? After reaching the end of a row, we have to go to the next block in the next row. The block's x coordinate will be 0 for the next row, and the row number has increased. We have gone to the next row. It means the y coordinate has increased and the x coordinate has become 0. So it's okay. Yes. Let's now move it. Okay. Now we will close the bracket of if temp greater than 0. No, before closing this bracket, I suppose I have already closed this bracket. Yes. there would be any error, it will come out. First we'll make it else if. Now suppose if we have not reached the end, we have to move normally from one block to another. Then else return solve x plus 1 comma y. Now that we have write the solve here, we have called solve again. It means that the function will run for the next respective block. Now we have closed the temp, if temp. We will then close the for loop. It's already been closed. Temp is closed and for loop is also closed. Suppose now we have come to a point where none of the value has been satisfied. 1 to 9, none value is satisfied. It means somewhere incorrect value has been put in. Now here we will write I equal to 10. When we will finish with all values, I will become 10. I plus plus I will go on increasing, and after the loop is ended it will become 10. We will write here if b bracket x bracket y not equal to a bracket x bracket y. It means if any value is already there and it's not correct, not equal to the original value, then we will make it 0. First we'll make it 0. For making it 0, b bracket x bracket y equal to 0, and after that return 0. We will return 0. It means that the value which has been put in is incorrect. We will return 0, the function will return 0, and it means we will go back to the previous block. Now let's see. Now this if b bracket x bracket y equal to 0, this, suppose now the entered coordinates are not of a block which contains 0, then what? Suppose there is a number in that block. Now we'll again have to write that how to move to the next coordinate. If x equal to 8 and y equal to 8, it means if we have reached the end, we will return 1. We reach the end. Or else if x equal to 8, if we have reached the end of one line, any one line, we will return solve 0 comma y plus 1, same as above. Or else solve x, return, else return solve x plus 1, solve x plus 1 comma y. Okay, now we have closed the bracket and we'll compile. 0 error, fine. It's correct, but we have to do one thing now. Let's see. We have put in the value in temp, but this value of temp we have not put in that variable in which we are solving the sudoku. So first we'll put in it bxy equal to temp. We'll do, or else it will not change the value of the sudoku. We'll do operations on bxy, na? That's why. Now we have to change something. Suppose we have started from here, 0, 0, we have to check like this. Suppose we have put in value in this block, we have to put in the condition of solve x plus 1 comma y. What we'll do is we will restart the function assuming this coordinate as the starting position. Now if after doing all this coordinate comes true, it means that the whole Sudoku is now true. Suppose we started from 0, 0, this is true, this returns true, means the whole Sudoku is getting solved. This and this if we have already put in, and the next coordinate is giving us true, then this means that the whole Sudoku is solved. Now we'll change something. We will do, instead of return solve, we'll put the brackets first. We'll write return 1, and when it will return 1, when solve, when if solve 0 comma y plus 1 is returning true. This means that if solve 0 comma y plus 1, this solve, if we have started solve function from this coordinate and this solve function from this coordinate is returning true, then the whole function will return true, return 1, hence we have returned 1. The same we will do with the rest also. Return I had put in just to make you understand first, but actually we had to do this. If solve x plus y comma y, x plus 1 comma y, return 1. Now again we are returning 1 because the whole Sudoku is getting solved. This whole function will get solved when the compiler will execute. The compiler will execute the whole function when the compiler reaches the end, and it will reach the end when x will become 8 and y will also become 8, x equal to 8 and y equal to 8. We have done return 1 here. Then the previous recursive function that would be running, this solve function x plus 1 comma, or any other solve function which would have been running, in that also 1 would have been returned, because suppose x equal to 8 and y equal to 8, it is what would have come before this, x equal to 7 and y equal to 8. So for x 7 and y 8, this condition would have been executed, this or the above one. So we will come to 8 comma 8. If 8 comma 8, then 1 would have been returned. If 1 would have been returned on 8 comma 8, then this means that this 7 comma 8, x plus 1 comma y, will also have returned 1. Similarly, it will go to the previous and it will also return 1, and 1 will be returned. 1 will be returned in all the solve recursive functions which would have been running. Same we will do here also. If solve 0 comma y plus 1, then return 1, bracket closed. Alright, then here also, else if solve x plus 1 comma y, then return 1, bracket close. Now compiling, warning, function should return a value. That doesn't matter because we have put the return value in test cases, so that does not matter. Now this done, this done. Let me check whether everything is alright or not. Yes, everything is right. Yes, now compiling once more. Yes. Now we'll write the main function. Now we have to write the main function. Void main. Yes, brackets. First we will take entry from the user in A for int I equal to 0, I plus plus, I less than equal to 9, I plus plus, for int j equal to 0, j less than 9 j plus plus bracket start, go to xy I plus 1 comma j plus 1, go to xy is for just for formatted output. C in a bracket I, a bracket I bracket j of for loop gets closed. Now single for loop is there, so only one bracket will get closed. Now we will copy a into b, similar like for loop for I equals 0, I less than 9 I less than 9 I plus plus for int j equals 0, j less than 9 j plus plus b bracket x bracket y equal to a bracket x bracket y. Alright, now we have to use solve function here. We will just see that the solve function is returning 1 when starting from 0 to 0 0. Now if solve 0 0, if it returns 1, then solution is there. Now if how we write the solution, so as b is a global variable, values would have been changed in it. Output value would be there, the solved sudoku would be there in b. Yes, now just we have to display it. For I equal to 0, I less than 9 I plus plus, for I j int j equal to 0, j less than 9 j plus plus. Same, go to xy I comma j, sorry I plus 1 comma j plus 1, cout b bracket x bracket y, terminate semicolon. Closing, we have already closed the for loop bracket. Yes, we have. Now is it finished? No, one more curly bracket here. Now if bracket is also closed, now if the sudoku would have no solution, then else cout no, sorry, in inverted commas, no solution. Alright, get ch system pause. Now compiling, 3 errors. What happened? Or a multiple declaration for j. No, that's not a big problem. Would have been same here also. 2 errors still. And event symbol x. Oh, I and j should have been there. Would have been there. Alright, that's not a big problem. Already my silly mistake. Now error 0. Now it's alright. Just now we just have to now check the output. Now it's the turn to check the output. We will test the output. We will assume that the red ones have been given already and the black would be replaced as zeros. 0490 4091. 06507. No. 570089. 102 060. Now 03204. Now 0050. Now 907 215 806. 06009. No. 0214 020210. 050503606007 7068 04301 14301 1 081 0700 040. Enter. Now the solution has come. You can check the solution. Let me reduce its size. Yes. Now you can check. It's same 645198273127346598. It's same. You can check after pausing the video. No. Finished. The video is finished. Thank you very much. Thank you.